Welcome to Building the Future, hosted by Kevin Horick. With millions of listeners a month, Building the Future has quickly become one of the fastest rising programs, with a focus on interviewing startups, entrepreneurs, investors, CEOs, and more. The radio and TV show airs in 15 markets across the globe, including Silicon Valley. For full showtimes, past episodes, or to sponsor the show, please visit buildingthefutureshow.com.
Welcome back to the show. Today we have Kyle Handfield. He's the managing director at Ventrify. Kyle, welcome to the show.
Yeah, no, thanks a lot. I'm excited to be here.
Yeah, I'm excited to have you on the show. It's nice to see a fellow Canadian working in an innovative space. But maybe before we get into all that fun stuff, let's get to know you a little bit better and start off with where you grew up.
Yeah, so born and raised actually in Edmonton, Alberta, here in Canada.
Sure.
Yeah, my family's been in Canada since 1847, actually.
Really? Wow, that's interesting. I couldn't tell you how. Well, I guess I could figure that out, but that doesn't matter. Interesting. So you went to the University of Alberta here. What did you take and why?
Yeah, I guess I'll just jump back and bring you a little bit through my life here. So
Sure.
I went into mechanical engineering right out of high school, and I didn't exactly know where I was going. I pursued a few other paths. I actually used to compete in culinary competitions, so I was actually looking at being a chef back then.
Okay.
But I ended up going into engineering, mechanical engineering, just because I'd always been fairly interested in designing things. I would call myself more of an inventor by passion. I always kind of got ideas coming up. So I ended up in mechanical engineering, and I worked through a few different industries, from the road construction, chemical plants, and then I actually ended up over in the product design industry.
Okay. So how did you make that transition?
Yeah. So through school, I did co-op terms at a number of different companies, and they were all right. But my biggest strife with them was just, you're expected to, spec a heat exchanger, and
Okay.
what do you get? You get a heat exchanger. So I didn't really
Shocking, right?
like the traditional. Yeah, I didn't really like the traditional engineering work.
Okay.
So I applied all around the world, and I ended up getting a job offer in Taiwan.
Okay.
And so I applied for companies all around the world, Dyson, to be a few that you actually have heard of.
Sure.
And then once I got this offer in Taiwan, I about 2 months later, I packed my bags, got on a flight, and showed up in Taiwan. I had about a month before I was starting work, and I had to figure out where to live, how to speak the language when I arrived.
Interesting. And you'd never been to Taiwan before, correct?
I honestly didn't even know where it was.
Amazing.
Yeah, like I looked at it up on the map, and why I chose to go there, I interviewed for a few other companies, one in the UK,
Okay.
was because I was Edmonton born and raised. I was looking for what is the most foreign, the most different experience that I could actually see, and what gave me the most opportunities to do something that was the most challenging and the most unknown to a lot of people over here.
Sure.
So the company I worked for over there, they design electronic products, but then they actually deal directly with the manufacturers in China.
Okay.
So that's how I got introduced into the China manufacturing, China industry, and I think that was the big lure to going over to China. Was I know Mandarin was a huge language for business, and
Sure.
it's you always hear about China being this place where everything's built, and a lot of cool opportunities, but nobody really knows what goes on behind the curtain.
Sure. Interesting. So walk me through that first month in Taiwan before you started your new job.
Yeah, for sure. So first I left Edmonton. It was a couple days before New Year's, and
Okay.
it was negative 30 degrees out. Got on the plane, and when I got off the plane in Taiwan 17 hours later, it was plus 34 degrees
Sure.
Celsius. So it was smoking hot. I still had on my sweater, and I had my 100 pounds of luggage. And I basically, when I got there, I went on Facebook and I started looking up, apartments, like where do I live?
Okay. Sure.
And I ended up settling up on a hostel. And the thing about Taiwan is they have a very vast network of trains and what they call the MRT.
Okay.
And I got lost in this underground mall. So I had to walk up like 7 flights of stairs, but ended up finding my hostel and set up a few places to check out for apartments.
Okay.
And from there, it went pretty good. The hardest challenge was not knowing the language.
Sure.
So my base example is when I first moved to China, I knew 3 words. I knew ni hao, which means hello, and niu rou mian, which is beef noodle.
Okay.
So the first month I ate beef noodles for an entire month. Just because you look at the menu, you got a bunch of Chinese characters, and I'm like, I don't know what's what. And some of the food, it's fairly foreign for me, so it comes out, and I'm like, yeah, I'll just order beef noodle. Beef noodle, I got pretty sick of it pretty quick, and then actually after you learn the language and infiltrate the culture a little bit, I think Taiwan is one of the countries in Asia that has the best culinary experience.
Interesting. And hence why you want to be a chef, right? Originally.
Yeah, I mean, I like cooking. I like eating good food more. So
Sure.
There was always that drawn to it, and it's just similar to the design industry. I guess you could draw a pretty good parallel in the fact
Sure.
that you come up with your SP, you design something, and it's all about the customer experience and how it tastes and how it feels in your mouth. You can compare that pretty linearly to developing a new product.
Yeah. No, that makes a lot of sense. So walk me through your day-to-day working in a design manufacturing electronics company in Taiwan.
Yeah. So, I mean, the way the company ran, there was a few project managers, and most of our clients were North American or European.
Okay.
And then we had a full design team. So I came on as one of the project managers.
Okay.
So I actually worked on a product which was a smart dog feeder.
Okay.
So you could Skype Fluffy, talk to Fluffy, or feed Fluffy with your smartphone while you're at work or on vacation.
Sure.
So it has a little train it that rotates.
Okay.
And so the day-to-day was a lot of, hopping on a call with the client or sending them an email at the end of the week, letting them know where we're at. And a lot of the design decisions you're making with the product are going to affect the cost. How much it's going to cost to produce and how much it's going to cost in the mass production. So there's a lot of benefit cost analysis that goes on, and a lot of actual communication with the customer you're dealing with. So most of my day-to-day was actually just working with the different teams, the electronic engineering team, the mechanical engineering team, the customer, and then also the factories in China to make sure that all these pieces were kind of fitting together.
Interesting.
So I had a good opportunity. I got to go over to China about 17 times.
Wow.
Through Hong Kong and then into Shenzhen, and I spent about a month in the factory or at the factory floor there doing some plastic injection molding parts.
Okay.
And here's the first tip for when you get introduced to a factory and you're looking to develop a product is they play this fun game when they get a new client. You sign a contract with them and they want to take you out for drinks to celebrate.
Okay.
So you get to the restaurant, you order a bunch of food, and you got the 7 or 8 people all from the company that take you out for drinks, and each person fills up their cup with baijiu or some other type of liquor, and they go around and independently cheers you and yell "Gangbei," and everybody, and you take a drink, and what they do is you drink for each time everybody else drinks once.
Got you.
So you can always tell the experienced people by they just get everybody to fill up a cup and take a drink at the same time. It's awesome. A funny little anecdote there.
Sure. So walk me through some of the things that you learned doing and being involved in the manufacturing process? Because you and I had beers last night, and some of the stuff that you were talking about from just like your experiences there, and actually what kind of goes on, and how to protect your property was really actually quite fascinating.
Yeah. Yeah, great question. There's quite a few intricacies to designing a product that's going to be scaled into mass production.
Sure.
So one of the big things that we do is we'll work with the factories early on in the start of the process, and that's for a number of reasons that I'll outline in a few examples. The first is the actual cost of doing, injection molds on plastic parts, and bringing your plastic part, through that design process. What shape and how you design the plastic part early on is going to strongly affect the cost in which you incur when you do that molding process.
Okay.
And that's why it's really important to deal directly with the factory that's going to be doing it. Whether you're working with a 3-ton injection molding machine versus a 4-ton machine, it's going to change how the part has to be designed.
Okay.
And so a lot of communication and collaboration with the factory you're going to work with early on in the design process is best. It's going to save you a lot of cost on the scaling, because they'll give you feedback on your design on how to make it more scalable and cheaper to manufacture the mold.
Interesting.
And then the second big part is when you're designing electronic products specifically. So hardware products is what we specialize in.
Sure.
A lot of times you'll build the prototype off of American branded Bluetooth products or prototype chips.
Okay.
And those are all great. It's quick. You can quickly move through the prototype stage and develop a workable prototype. But what you end up doing is when you go to actually manufacture your product in China, you're not buying those $4 Bluetooth chips that you would buy as a prototype here.
Interesting.
You're going to buy the 70-cent board or 70-cent chip that you'll get from a China supplier.
Got you.
And the big problem with that, or the challenge with that, is the brand name Bluetooth chip that you see in America. It has a software suite to help you program your firmware onto it. It has a bunch of libraries you can use that'll simplify your code. When you go to that Chinese version, you're going to have to write the firmware directly in like Objective-C, and you'll end up doing a lot of extra rework if you didn't consider this early on in the process.
Okay.
And so that's a lot of what we do is, help educate our clients on, what can we do earlier on in the design step to avoid any rework in the future.
Sure. So walk me through you moving back to Edmonton and starting Ventrify, and what exactly is it? Yeah.
So, the company I was working for overseas, I saw that there's a big market for hardware products, and then helping scale and supply products in China. But what I think the biggest thing that was lacking was a local connection. So a North American company that works directly with our clients.
Sure.
So that's the reason why we're setting up here in Edmonton, Alberta, Canada, is so that we can work directly locally with our clients here. So we'll do the first about like month or two of the prototypes here in Canada, where we go through and do the product feasibility studies.
Okay.
So we'll look at how much it's actually going to cost to make as a unit cost in China before we actually make a lot of those design decisions.
Sure.
And then we'll go through a really detailed design thinking industrial design step.
Okay.
So that's where design thinking is looking at the problem from a user perspective.
Okay.
And so really digging deep into how the user is going to use it, what environments are they going to use it in, and how to make the most user-friendly experience, how to make a product that's competitive on the market. And then the latter half, where we do a lot of the detailed design, electronics, and the plastic parts, we'll actually do that over in Taiwan.
Sure.
Utilizing some of the great talent over there. So that was the vision behind Ventrify. So we launched about 6 months ago now.
Okay.
And what we offer is we offer complete design services from idea all the way through to mass-produced products delivered on your doorstep.
Very cool.
And the big three reasons we see clients working with us is number one is because they're trying to get to market with a pretty competitive timeline. So they're looking for a partner that can bring them through that scaling process.
Sure.
Number two is the only way that they can compete in the market is with a, outsourced manufacturing solution. But, they don't know all the steps that it's going to take to really go through that process.
Right.
So we'll assist them with two big problems. And number one is quality control.
Sure.
And number two is actually the intellectual property protection.
Right. Interesting.
Because the two biggest things that I see clients coming to me and saying, hey, Kyle, I got this great idea. I'd like to bring it to market, but I'm really worried about, getting it mass produced in China because I think somebody's going to rip it off.
Sure.
And so Ventrify addresses that in a couple different ways, but the main or the most important method is I get a lot of clients who ask, should we patent this? Should we get a design patent on this technology? And more often than not, that's not something I'd usually advise to clients.
Okay.
So how we tend to protect the products is if you're making an electronic product, you have, the hardware chips, you got the firmware, and then you got all the the plastic parts and the other components. We'll split those up between multiple factories in China. And where the actual intellectual property value comes in is combining the, hardware platform with the actual firmware and software that goes into it.
Sure.
So we keep all the puzzle pieces spread out between multiple suppliers, and then we'll actually assemble it all in-house. And that's one of the biggest deterrents for protecting your intellectual property.
Sure. Because actually getting a patent in different countries is really expensive, correct?
Yeah, and so in Canada, America, you'll spend about $15,000 from start to finish filing a patent.
Okay.
And then on top of that, and that's for each country you want to file it in. But then on top of that, it's not a right that you have that nobody can go ahead and steal your idea after you have a patent.
Sure.
You have to go out there, identify those people, and then take legal action to make them stop selling their products.
Right.
So you generally have to have, pretty large capital requirements or capital backing to really protect a product or an innovation that you have. And so that's why I think, if you can develop some traction on the trade secrets, more often than not, the big guy's not going to try to reverse engineer your product. What they'll do is they'll come to you and, look for a licensing or a acquisition deal.
Right. Okay. Interesting. So walk me through a little bit more of the process. So you said kind of from idea to putting it on my doorstep, but how far along do I need to be with my idea before you guys can really help me out?
Yeah. So we can help people out. We have a few clients that we're working with, and we're starting with them, and they've already designed their product. They just need somebody to deal with the quality control and mass production in China. So, we can, start working on a project anywhere along the chain of events. But, the ideal or the best customers are really two different ones. Is number one, we have a customer who, has well-defined what product they're bringing to market. They understand who the customers are using it. And at that point, we would bring them on at the, industrial design phase where we'd start looking at designing the product around building something that can be scaled and something that can be sold for the unit price available.
Okay.
But then the other client that we get that's, I would say even a little bit more popular is somebody who comes to us with a problem.
Okay.
And they say, hey, Kyle, we have this problem with our supply chain. We're looking to put some sensors in it so that we can get some real-time feedback on our process. How would we go about this?
Okay.
And so with that, we offer a service, what we call innovation consulting.
Okay.
And the big part of what we do is we bring the knowledge of what's possible out there, and we help them identify what's a solution that could be applied to their business. And the big steps are, they're considering whether or not they're going to go ahead with this project. Most electronic products, depending on the complexity, will range between about $100,000 and $1 million to bring to market.
Sure.
So it's a pretty significant investment.
Yep.
So we'll work with them to develop a product specification document,
Okay.
Which basically outlines all the features in it, a market research or market requirement document, which basically looks at, what are the competitors out there? And this is actually where the quality control starts. And then the last part is we'll build them a product roadmap. So what that would tell you is, what are all those hidden costs of bringing this through the supply and through that scaling process, such as the cost of an injection mold, the cost of certifications. And if you're going to sell a product in America and it's an electronic product, you have to get your CE certification. You have to get your FCC certification. FCC is your if you have any wireless, or if you have Bluetooth or Wi-Fi on your product.
Okay.
And all these certifications, they add up in costs. So we generally, a good ballpark number would say, put aside about $10,000 per certification you're looking at getting.
Wow.
But a lot of what we can help at this point is, we'll help you understand what are all those hidden costs of bringing a product through that scaling process. What are the costs of shipping it? So that at the end of the day, you've allocated enough capital that you can bring this product to market successfully.
Sure. Yeah, because there's nothing worse than you get halfway through and run out of money, right? Or 3/4 of the way through, or even 95% of the way through, right?
Yeah, and I mean, that's the kind of frustrating part is because, hardware products as, a startup entity, for example, have a really bad rap of, being very expensive and always taking 4 times as much money and 4 times as long as you expect to bring to market.
Yep.
And a lot of that goes into just the complexity of the process that you have to do to bring that product from idea all the way into, the consumer's hands. So a lot of that can be avoided with this, planning phase, really understanding the costs. I'm going to go out there, and anybody listening who is looking at bringing an electronic product to market, a great resource is actually a book, and it's written by a guy named Phil Baker.
Okay.
And it's titled From Concept to Consumer: How to Bring Ideas to Life.
Okay.
I think that's what it's called. But it's, it really helps outline all these different processes.
Okay.
And that's a resource that, even we use in the company to help train new employees coming on board.
Sure. Makes sense. So you keep mentioning a quality control, and I know that's super important, but why is that so important, and how do you guys handle that?
Yeah, I mean, it all comes down to the consumer, right?
Sure.
You sell an electronic product out there, and electronic products are usually, or tech products are usually fairly expensive products, but especially today with the online reviews and whatnot, it not only will hurt your reputation, but it can cost you a lot in RMAs, which is return to manufacturer, or even just sending out or like fixing or doing maintenance on the units.
Okay.
So one of the things we really focus on in our product development experience is building products or building quality into the product.
Okay.
So not necessarily, verifying that, the quality was built properly. That's a secondary step. The first step is actually understanding, where are these products going to be used? Are they used in negative 30-degree weather? Are they used in humid environments? Do they need to be waterproof? A lot of those questions, if you ask those at the start of your design process, you'll end up building a product that can be, a lot more robust, will build your brand reputation around, quality products that don't fail. And that's where you'll make a product that'll continue to be successful in the market and continue to sell for a number of years, rather than, being that big flashy product that gets out there and then, there's a few people that have big problems with it. And, you read a few reviews and you decide to go with the competitor.
Yeah, interesting. No, that makes sense. So you guys physically will have somebody in Taiwan that is actually going and checking the manufacturing process, right?
Yeah, so we do 2 big things. Is the first is when we're actually setting up those agreements or those supply contracts or manufacturing contracts, we'll get the factories involved early on. So, 2 to 3 months in the design process. And what that does is not only for the actual expertise of the factory, but it makes them invest a little bit of their own time and energy into getting that contract with you, and you start building a relationship of trust.
Okay.
And that's a big component, especially when you're working with Chinese or Chinese manufacturers. Is, a lot of business is built around trust and relationships there. So the longer you can, have a relationship running with somebody, the better quality you can expect out of a product.
Okay.
But then the second thing that we do is, we'll send people on or to the ground floor of the factory where your products are being produced, and we'll assure the quality of the products coming out. And a lot of it isn't that we are really changing a lot about the manufacturing process,
Okay.
but it's demonstrating that local presence. So
Sure.
having somebody there to, keep them accountable. So when you're just building a product and you're producing 100,000 units, when you're in an 8-hour shift, I'm sure it can, in the middle of it, it's hard to keep focused on, really watching for those quality control issues,
Sure.
especially if your client's a number on a paper.
Yeah, interesting.
They're a foreign company in America. So a lot of what our value is developing that relationship with those suppliers and then having that ongoing continuous presence. So rather than catching those quality control mistakes once it's been, assembled, shipped all the way over to America, we can catch them on the ground floor at the factory before they even ship over to America, and saving money. But often money's not even the biggest problem. It's getting those products with an on-time delivery.
Yeah, interesting. Because you hear it all the time, hardware projects get delayed months or years, right? Like that. I think that's almost what's been happening with a lot of hardware products that launch on Kickstarter is they just never ship, or they ship so late, right?
Yeah, and that's a great example. Kickstarter is a great example for that. If you look at Kickstarter, the actual projects that have been successful and gone on to make multiple new products, it's all the products that got the companies that got their products out to the consumer within a couple months of the Kickstarter closing. And, there's a lot of value, a lot of importance in that. And that's something that, often people don't think about till after they get their sales is, they get all these sales and then they go, oh, well, now we should set up manufacturing, and now we should, start working with our suppliers in China. As an afterthought, it can only go so far.
Sure. Interesting. So it sounds like pretty early on then, right? Like, which makes sense. I totally get why you would involve them as early as possible.
Yeah. We, there's two big reasons you involve them early on, and it's number one is for the quality control and that building that relationship. But the second is when we actually go through and are starting to build that budget. So understanding, if you have this feature you're adding into it and it's going to cost, an extra $100,000 to build and implement, is it actually worth it if it's going to cost, an extra 40 cents to add to the product's unit cost? Like, what are you selling
Sure.
with compared to competitors? So really balancing what's the actual benefit that a consumer gets out of it versus the additional cost on mass producing it, the actual unit cost, and number two, the additional cost of all the engineering and time that goes into building it.
Sure. And then I guess you could reach out to the factory too and get them involved and say, hey, we're thinking of adding this in. Maybe we add it in version 1 or version 2, depending on cost, right? Or maybe not at all.
Yeah. And I mean, so there's this a lot of people I talk to have this perception of manufacturers. They always ask me, hey, Kyle, you guys sound connected. Like, do you guys have, 3 or 4 manufacturers that you work with in China and they do all your products?
Okay.
That's not exactly how it works. Each factory has its own specialty. They produce, one type of product, and they're really good at producing that type of product.
Okay. Like,
and
what would be a type of product? Sorry.
For example, you could see the smartwatch. Let's take a kind of a Fitbit type product, for example. Somebody who's designing and building a smartwatch needs to know how to build an electronic product that is going to be waterproof.
Okay.
Sure. For example, that factory is going to have learned a lot of lessons about, how to make waterproof, how to manufacture and assemble products that are waterproof. So working with somebody who's done that before is going to save you a lot of costs compared to working with a factory that's, never done that and has to go through that learning experience.
Sure.
And the other thing that a lot of people don't really pull off of is the actual experience of the manufacturers.
Okay.
They've been designing products, fairly similar to what you're looking for. If you're looking for a battery pack, they've probably designed 100 battery packs in the past. And that's where you can get some really early feedback in if there's any problems that are going to come up with how the product's being assembled or how the product is, being manufactured. So that's a big value of working with those manufacturers from the start is, they make the stuff. They can look
Sure.
at it and tell you, yeah, it's going to work, or no, it's not going to work in terms of how it's actually built and put together.
Yeah, no, and that's invaluable, right? Because you could if that cuts out one or two or more versions of a prototype, then you can save a ton of time and money, right?
Oh yeah, you can save months, and some products are, it's fairly important to get it to market in a reasonable time. You only have a certain window
Sure.
on a lot of the products that we're looking at bringing, because you got competitors who are maybe developing similar products, or you have the technology landscapes kind of moving forward, and you got Bluetooth 5.0 coming out next year.
Yeah, interesting. And then even knowing when to upgrade your current project or product, sorry, to the next version of something, like going from, the current version of Bluetooth to the new version of Bluetooth, right? Could add a huge amount of cost that you may or may not need.
Yeah, it could add a huge amount of cost, or it could also add a lot of value.
Yeah,
One
fair.
of the biggest steps that I've seen in the last couple of years is going from Bluetooth protocols to the Bluetooth low energy,
Yeah,
BLE.
sure.
A lot of products that are available today take those tile trackers for your keys.
Okay, sure.
You put these trackers on your keys and your wallet, and then you can use your phone to locate them if you ever lose them.
Sure.
Those use Bluetooth low energy. That's something that wouldn't have been possible using the old Bluetooth protocols, because it's a much lower energy requirement. So your battery life would last a year on those products versus maybe it would have lasted a couple weeks, a couple months.
Sure.
And having somebody who understands what are those opportunities out there and how they can really fit into your product can add a lot of value.
Yeah, no, that makes a lot of sense. So what advice would you give people that are doing their own hardware startup? Because it's really, really daunting.
Yeah. So the big thing is, number one, really do your research. And I'm talking about doing your research on what are all the costs and the timelines associated when you're looking to raise money, you can raise, enough money to actually make that product successful. Number two, don't reinvent the wheel. There's a lot of great components or, chipsets that you can integrate into your product without having to redesign, for example, the networking or the, IoT sensors. There's a lot of great products out there that you can integrate in your design without having to, redesign them from scratch.
Okay.
And then the last thing is, apply the lean startup method.
Okay.
Really, really look at, what the customers want and put it, develop a minimal viable prototype or minimal viable product,
Sure.
and get some feedback on what are those actual valuable features and valuable parts that are in the device, because it's gonna save you a lot more money to change your design early on in the prototyping phase rather than once you've gone a little bit deeper into the detailed design.
Sure. So typically, how many prototypes do you usually see? Like, it seems like there's at least 5 or 6 versions in most cases that you go through, sometimes less, sometimes more.
Yeah. So I'd break the prototypes into a few different phases.
Okay.
So the first phase is what we tend to refer to as like an aesthetic prototype. So that
Okay.
is how the product looks, how the product feels, and how the consumers interact with it.
Okay.
So if you're making, I don't know, for example, a heated coffee mug,
Okay.
what size, what shape do you make that coffee mug? And, what are the ideal temperatures that you got to have that keeping the liquid at? Those are the kind of questions you ask during that aesthetic prototype stage.
Okay.
And then so you usually go through a few iterations of those. and those are often using, 3D printing and other rapid prototype methods.
Right.
And then you'd really jump into the electronic prototypes.
Okay.
So during this phase, you got the first one is usually done using a prototype board. So that would be something like a Raspberry Pi or an Arduino.
Okay.
And basically, this is just a proof of concept. The tech exists out there. This is how it can be done, and you can start testing some of those questions you had on the technical feasibility.
Okay.
And then the next step would be actually integrating that prototype electronic prototype board and building a printed circuit board.
Okay.
So making your own custom electronic board that's going to fit within the shape and size of your product. That's what we usually refer to as, electronic PCB prototype board.
Okay.
And then the last step you're going to do there is you're going to do all the, mechanical and assembly prototyping. So that's where you're kind of going through and looking at how does this product all fit together? How does the circuit board mount to the mechanical or like the plastic enclosure? How does it interface with an app if you're building an app with it? And so these are the points where you got a product that looks, it feels, it works just like it would once it's mass produced, but you haven't even really delved deep onto figuring out, how this thing is going to be, mass produced and really optimizing for some of those mass production processes.
Okay.
So then the last prototype, which I don't know if you quite can consider still classifying it as a prototype, is when you're doing your first pilot runs with the factories.
Okay.
So you produce, 10 to 15 units and you make sure that, they all fit together properly. And a lot of what those are used for is reducing cost of assembling an electronic component. Because the more complex of a product you have, the more time and money it's going to cost to actually put it together.
Sure. And then who do you usually get to put it all together? Would that be you guys, or do you outsource that, or how does that work?
So on a product that, it's fairly non-unique, and, you see a lot of other similar competitors out there, we'll usually just work with the factory that's producing some of the main components to assemble it.
Okay.
But anything that is, a really unique, custom product that, you're worried about protecting your intellectual property, you can afford to pay a little bit higher price, that's when we're going to do it in-house, and we'll ship all the parts from Taiwan and then from China and assemble it in Taiwan. And that's for a couple of reasons. Number one is we can check the quality of all the internal components in the product as well as the whole thing.
Right.
Number two is that intellectual property protection. And number three, it's getting more and more difficult to import China-made products into America due to, some of the new tariffs and import regulations that are coming up with the new administration. It's always an ever-changing landscape. So, depending on the product, that's when you'll kind of look at whether you're going to do it here or there. And I've even seen a few products being manufactured in America or in Canada.
Okay.
And that's because military products actually have to be made in the country.
Oh, I didn't know that. Interesting.
Yeah, so you have to assemble or manufacture most military products for military contracts on like their local territory. So if you're working with the American military, it has to be produced in the U.S. And that's where I see a lot of that. Everybody's always asking is, what do you think about decentralized manufacturing? A lot of small local manufacturing sources, and how the outsourced manufacturing is kind of going away. Right now, China's the best place for electronic products because they got the component supply chain. They got a lot of the resources there. But yeah, there's definitely some other industries out there that require manufacturing in a more local setting. And that may be because the parts are, very heavy and big, and it costs more to ship them over than it would be to, produce them locally.
Yeah, interesting. No, that makes a lot of sense. The other thing that's interesting is we were talking about it yesterday, is people are still so against, well, not a lot of, some people, I guess, are very much against offshoring content or design or development or manufacturing, but it's so much cheaper in a lot of cases, right? Is that fair to say?
Yeah, 100%. So like the general rule of thumb that you'll see in resources textbooks, and what I kind of refer to people is, if you're producing, a technologically complicated item in China, you want to have an order value of about $100,000.
Okay.
And the reason for that is, what it does is, it's a lot of the factories you work with will have a minimum order quantity.
Okay.
So you have to order products in minimum 1,000 units or a minimum 10,000 units.
Okay.
And so to actually do that, you're going to have to spend a bit more money. But then the second thing is your priority level at the factory.
Yeah.
So, I mean, you can convince factories to produce you a couple hundred units, but when push comes to shove, you're not going to be their number one priority. They're going to prioritize the big clients that have, the larger dollar value orders. So I usually suggest, you kind of want to keep it for like the long term. You want to order around minimum about $100,000 in a year dealing with the factories, just so that keeps you relevant in their books, and it makes the most fiscal sense to actually manufacture the product there. I guess the stigma that's still existing around offshore manufacturing or outsourcing pretty much anything, it kind of comes down to that 90-10 rule. You got, 10% of the service offers out there that actually, they don't, or they usually don't give you that good of quality work. And it's, those few horror stories that get passed around that really, build up that image and push a lot of people away from, trying to dive into the manufacturing outsourced in, China or India is actually a huge, growing a lot in their manufacturing of like plastic products.
Sure.
But really when it comes down to it is, there's always a risk you take when you're working with a foreign entity that you don't know, and maybe you don't have huge visibility in terms of, where they're located, and you can't visit their office. And then the second thing is having that local presence. And that's a lot where, companies like mine can kind of fit into that puzzle and help you, still take advantage of those outsourced manufacturing opportunities, while giving you somebody to help you, limit that risk that's on the table there. So, I mean, I have heard, some people that have, really struggled with manufacturing in China, but the reality of it is more often than not, even if you're having some quality control issues, you can still buy twice as many products from China for the same price as the ones you're going to buy here. So,
sure.
Like worst case scenario, you discard the 30% and have them sent back to the factory to get redone. And you're still, saving money or spending a similar amount of money. So it's an opportunity on the table that, a lot of people are shying away from, but I don't think it's going away, anytime really in the very close future. And it's just, a lot of it has to do with China has the supply chain for it. They produce all the electronic chips, and they just have the big supply chain for mass production.
Sure. So how important is understanding the language, or can you get by in a lot of cases just speaking English to somebody at the manufacturing plants? Yeah.
So I always put it this way is, like, first time I went over there, my Chinese was definitely not passable.
Okay.
So it can be done. What I found is, if you're going to be dealing with the factories directly without a third party involved, I would strongly suggest that you bring on a translating company, or you speak the language. But a lot of what can be done is there's a lot of factories and sourcing individuals on the site Alibaba.
Okay.
And Alibaba is basically like Amazon, but they deal with like wholesale products coming from China. And what they'll do is everybody on there who's dealing with you, speaks reasonably well English. But on top of that, Alibaba provides some protection in the circumstances where, your contract didn't end up holding up their end of the contractual agreement. So maybe they didn't deliver the products. That's where, a platform like that helps you actually secure those risks and get those products. And it's very important that if you're going that route, where you're not working with somebody to build a relationship and, setting up all those contracts yourself to keep all communication on that platform.
Makes sense. That's good
Because
advice.
anything, they'll try to, a lot of the really, experienced manufacturers, or there's a lot of reselling companies who work with the factories on your behalf on there. A lot of the really experienced ones will put the stuff that, they don't necessarily want in the contract. They'll try to discuss that over email
Okay.
or over the phone. It's
Sure.
important to have that in writing and on the platform you're working with.
No, that makes a lot of sense. That's actually really good advice. So we're kind of coming to the end of the show, but is there any other advice that you would give people looking to do a hardware startup or add hardware to their current business?
Yeah, it's hardware's, it's complicated. It can take quite a bit of an investment. But the biggest step would be, before jumping in and starting to, work on developing a prototype for your project, really look at the market, understand where the gap is, where you have to design your product, and do a really detailed analysis and understanding of what are all the costs and investments that it's going to take to bring this hardware product from that idea into the consumer. Because that's the number one place that I see startups failing is, they come to us and they haven't really spent enough time or enough money or energy evaluating, who's this product for, how is it going to be used, and to actually sell it in our markets, what do we have to make it for?
Yeah, interesting. Yeah, well, and the other thing too is you mentioned something earlier that got me thinking is like a Raspberry Pi or something similar to that. You can build a pretty good, really, really rough prototype with some pretty expensive hardware that already exists, right? And maybe you write a little bit of software to it, and it's probably nowhere near what you want it to be, but it would probably be enough to start getting some early feedback or testing it on your own. Is that fair to say?
Yeah, no, 100%. And
we're talking
yeah,
a few $100s, right, to get there.
It'll cost you a few
less.
$100s, but it gives you the same ability to test whether, if you're testing whether your Bluetooth network will have enough range, or
Sure.
a lot of the technology in it is the same stuff. It's just packaged in a way where, it's easy to prototype, and that's what it's built for. So
Sure.
yeah, take advantage of that. Start getting some early customer feedback, because anything you do in that prototype stage where you're not investing big dollars into, electronic PCB design and whatnot, is going to save you a whole ton of money down the line and really allow you to validate your project.
Sure.
So I agree 100% with what you're saying. And then like the second like big point or tip that I could give with using a lot of these Arduinos or Raspberry Pis to build your design is, everybody always asks, how much is it going to cost to make my project? Well, you could develop something for 10 years and you can always make it better.
Sure.
You can always make it more perfect. It's set a minimum viable product, so the minimum design that you need, and then test it and then add to it. You can always continue to develop it, but you got to set an expectation of understanding where you want it to end up, because there's always ways to make it better. There's always ways to, continue improving it. And at some point, you just got to get it out there to the customer and get some real feedback. And then, in version 2.0, that's when you can really add a lot more value.
No, that makes a lot of sense. And I've even seen guys or girls use like Lego to hold things in place, or cardboard, or like, it doesn't have to be, it can be pretty crude, right? To get that kind of first version up and working and you playing with it. Is that fair to say?
Yeah, you don't have to spend a whole lot of money, and by no means do you have to, go out there and get the best and the craziest, most expensive stuff. Just the easiest way to start is to get started doing something. And I actually love cardboard prototypes. Okay. I think they're, one of the best steps you can take moving forward. But yeah, just start applying the lean startup method and, develop a product and get out there, get some feedback, get some user feedback, and then, modify your design, improve your design. And once you have really validated the market, once you've validated, that your product's something that people are going to actually use, then is when you're going to start wanting to take some of those steps to look at, okay, well, how do I build something that's going to be able to be scaled and mass produced and, sell to consumers?
Sure. No, that makes a lot of sense. But Kyle, we're coming to the end, so let's close with mentioning where people can get more information about you guys and any other links you want to mention.
Yeah, for sure. So you can go ahead and visit our website if you want more information. It's www.ventrify.ca, and that's ventrify.ca. You can also go ahead and send me an email at kyle.handfield@ventrify.ca. And I think that would be two of the biggest places to get a lot of information about designing and developing your product. And then the last thing is, I can't recommend it enough. I think it's one of the most valuable books I've read, and it's that Phil Baker book, Concept to Consumer: How to Turn Ideas into Money. I think those are a couple of the biggest resources. And then other than that is just read a lot of blogs, do a lot of information, and just start connecting to those people who have developed products and hardware products in the past, and start asking them some questions on LinkedIn or give them a call.
Perfect, Kyle. Well, I really appreciate you taking the time out of your day to be on the show, and I look forward to keeping in touch with you, and have a good rest of your day, man.
Yeah, for sure. Thanks a lot.
Thanks,
and we'll talk again soon.
Sounds good. Okay, bye.
Thanks for listening. Please visit our website at buildingthefutureshow.com to join the free community, sign up for our newsletter, or to sponsor the show. The music is done by Electric Mantra. You can check him out at electricmantra.com and keep building the future.